what is a factor? What does it mean to be a factor of a number, right? Yeah, there we go.
A number that can be times with another number to make that number.
Okay, so say that again. So a number that can be broken up and multiplied together to get another number. Yeah, that's well done. I love that explanation, right? When we're thinking about factorizing, here's two things we're thinking of. We're thinking about like two things, and if they multiply together, they give me that original thing. That's exactly what we're looking at. We're looking at factorizing. But factorizing algebraic expressions is slightly different because it's easy to know that 2 times 3 gives you 6. But remember, I introduced this kind of visual way of thinking about algebra, right? If I think about it, the question is asking this. If I have the area of something, 5x plus 30, and maybe I know one of the side lengths, 5 over here, if I'm asked to factorize this, I'm really asking, what's this length going to be? What is that going to be? I'm thinking, I want something times something that gives me that one. Go, Eloise.
X plus 6.
Let's see. X plus 6. So you're saying if I have x plus 6 here as one of my side lengths, if I multiply these together, I should be able to get what that's going to be. Can we check that? Yeah, how? How could we check that?
We can divide the main answer.
Ah, so now we're talking about division. But think about how did we actually expand in the first place? What did we do? Oh, no, so Max, go. Are you ready to go? Yeah.
You multiply.
Ah, exactly right. So we can always check our factorization, which is actually what we just did, by expanding it out. So let's check that now really quickly. 5 outside of x plus 6, and multiply that out. Remember, everything on the inside by the outside, and indeed we do get 5x plus 30. Can you write that down if you didn't get it for me? Can you write that down if you didn't get it for me? Ah, is the opposite of multiplying? That's a good question, right? Okay, so factorizing. We know what factors are. Two things that multiply together that give me something. And we can see here that's exactly what I've got, right? If I looked at 5x plus 30 and I said, what are the factors of 5x plus 30? You might say, well, here's two things that multiply together to give me that expression. Would you guys agree with that? Right, that's what I'm trying to say here. In the same way that 2 and 3 are factors of 6. Now, this is just an introduction to factorizing. In algebra, when we're factorizing, there's actually many different ways to factorize things, right? But this is the basic idea. I want two things that multiply together that give me that expression. With algebra, though, there's a few different strategies we can use, and here's one of them, right? To factorize an expression, we can think about that, as Jackson said, as the opposite of expanding, right? Because if you think about it, what's actually happening is you're going backwards, aren't you, right? I started off, usually when I expand something, I multiply it out, and I get something like this. Factorizing is kind of going backwards and saying, how do I get back to what I started with, right? When I am doing that, here's a strategy that we can do, right? Because I know when I am going backwards, what am I actually introducing? What's different here? There's brackets. So maybe you want to think about factorizing as introducing brackets, right? And I think we could kind of see how we did that. But does anyone want to tell me what operation did I do here to actually introduce those brackets? If you maybe think about it, what operation did we do to expand these brackets? We had to, what did we have to do here? We had to multiply. So if I wanted to go backwards, what operation would I have to do? I'd have to, Sunny, I'd have to divide, right? Can you see that? So we have to divide, but I had to divide by a specific number. What number was that? It was 5. Now I want to think about how did I get there? What's actually happening is you're dividing by what we call the highest common factor. So it's saying what's in common between all of these terms here. So essentially you're saying what's in common, right? What's in common? And it can be whole different things. It can be numbers, it could be letters, it could be anything. But in this one, I can see very clearly what's in common between these is there's a common factor of 5. So I'm going to take that out in a sense, and then I'm going to divide each of these by 5, right? I'd get left with x plus 6. And we did that already, but I just want to show you how we can do that algebraically, right? Without having to actually draw that rectangle over there. Let's have a look at this one. Can anyone see what's in common with this one here? Sunny, yeah.
It's half of the number.
Half. So you mean like 6, or what do you mean half of the number? They're both even numbers, is that what you're saying? Or? Yeah, they are both even numbers. So maybe you could take out a common factor of 2. So I say 2 outside of, well, what's 12 divided by 2? That's, and then I've got 14. How do we feel about that? We can keep going. Okay, so this is why I've used a specific term, the highest common factor, okay? That is a common factor. 2 is a common one. But I want the highest one there is, okay? So let's try that one again. Is there a bigger number that goes into all of them? 12? So 12 goes into 28? Not quite. 4. Someone said 4. Let's take out 4. Let's see what happens then. So what do I get left with here? I get left with... So I'm doing 12 divided by 4, because remember, it's what's in common. I'm doing division here. So 3a, yeah. And then what's 28 divided by 4? That's 7. That's right. And that's what it means to factorize. I've done all of these things. It's the opposite of expanding. I'm introducing brackets, and I looked for what's in common. Does that make sense? How do we feel about that? Again, how can I check something like this?
No, you're timesing that.
No, you expand it again.
Good, right. I can expand it again, and I can get back to the original thing. That's how you can always check expanding and factorizing. Because they're opposites of each other, you can always check it. And I can even factorize something like this. It's much larger numbers. But can we see what's in common here? This one's a bit trickier. Mannix?
9.
9.
8. So
9 and 8.
Goes into, so we do 8 times.
Yeah.
And then 9 goes into 48.
Oh, no, we can't do that one. Okay, let's try again. That's all right. This is why we're learning, right? Does anyone have another idea? Yeah, go, Louise. 12. 24. Or even bigger. Okay, 12, 24. Can I just say, you guys, none of you guys are wrong. Okay, none of you guys are wrong. But we can just do better, right? Because we want to, and I should probably add it on here. When they ask you to factorize, they are asking us to factorize fully. So you want to take out everything that you can. Can we take out 24 here? What do I get left with?
3.
Plus 2x squared. Are you guys happy with that? I'm cheating here. There's actually something else we can take out as well. I don't know if you guys can see it. Like I said, we can take out numbers, but we can also take out, Isaac?
24x.
Ah.
So we could do 24x.
We could take out the x variable as well, can't we, right? And remember, what does it mean when we're taking something out? It means I'm dividing, right? So if I divide this by x, what am I going to get left with here? I'll get left with 3, because that x will divide through. But remember, I've just rubbed it out. But remember, if you think back, x squared divided by x, what's that going to leave me with? That's just
X.
one lot of x, right? Yeah, because this is the same as x times x, and that divides through and leaves me with that. So I get left with 2x, okay? And again, we can always expand it back out to check. Now, I use this word factorize fully. And generally, they don't really like having negatives, so we want to take that out as well, okay? If I want to take that out as well, I can see there's a common factor of 5, or I can say there's a common factor of -5. What's that going to look like now? Be careful with this one. I know I'm going to be left with x here.
So you want to put 5x. Oh, wait a minute.
Oh yeah, because remember, x is not in common between, it has to be in common with all the terms, right? Otherwise I can't take it out. Jackson, what am I going to do?
5 is common.
Yep, so I've taken out -5, because remember, we don't like the negatives in there as well. So x minus 3, how do we feel about that?
No, plus
No.
3. Plus 3, because there's 2 minuses.
Okay, remember, we can always check this, right? If I expanded this out, like, let's say I thought this was my answer, I'd get -5x, negative times a negative is a positive. Oh, I got something different, right? So the beauty of this, that's okay, we're still learning here. The beauty of this, you can always check your answer, and this actually does have to be positive, because if you take out -5, so negative divided by negative, that does give me a positive. Okay, does that make sense? Yeah. Any questions about that one? Let me put up some more examples for you to try.